G'day folks, and welcome to Gorman's Shed. I'm Brian Gorman, and I'm going to show you how to make my rotating magnetic coupling. This is a fairly recent invention of mine, I suppose. I'm not aware that anyone else does it. As far as I know, I'm the only one, so I'm going to show you how I build it. This is the coupling I'm talking about, and you may have seen it in some of my previous videos and a demonstration of how it works. It's rotating in the sense that the magnets can rotate within the coupling. Now, the way this is made, it's all made from household copper wire. Now, this is a strand out of a multi-strand piece of cable, and these strands of copper wire are 0.8 of a millimetre in diameter. And you may think, well, you know, copper's quite soft, but when you get it down to these quite small dimensions, it's actually quite rigid. And it's like anything that may be what is perceived as soft. The smaller the part of it is, the more robust it becomes. And for this system to work, as you probably know, on my layout, which has some tight radius points, it requires a wire across the buffers, which is phosphor bronze. That's about 1/4 of a millimetre in diameter, and that's absolutely necessary on my railway. If your railway has large radius points and very moderate sort of radius curves in it, this may not be necessary, but certainly on my railway it certainly is necessary. Anyway, I'll take you through the process of how we make one of these. And I also should point out the reason I'm using copper. I suppose you could use brass, but you need something that's not attracted to a magnet. Even down to the axle that holds these magnets here. I was trialling metal staples, which are magnetic, and they do work reasonably well. I mean, you could do it that way, but in some cases this magnet would be attracted to the staple on the opposite magnet before it's attracted to the opposite magnet. So by using all copper here, I have none of those false attraction issues, if you like. So that's why I've gone all copper. And the same applies to this wire here, which is not attracted to a magnet. So yeah, it cancels out a lot of problems. So this is the type of cable I'm talking about. There's 7 strands of copper wire in this. This is intended for use on 240 volts throughout the house in Australia here. What you use overseas, I don't know, but it really doesn't matter. What we're more interested in is the actual diameter of the copper wire. You could probably use a smaller diameter, but the smaller you go, the more likelihood of the coupling bending under stress. So I've done some extensive testing with couplings made from this wire, and they don't change. They just, you know, remain as they were made. So that's why we're using this. Now the first thing I do is I cut myself a length of copper wire. I've cut quite a short length here, about 150 mil here in this instance, just for this demo. But what I like to do is I like to straighten that wire. So you don't have to straighten it. I mean, you could get a reasonable sort of effect by running it through your fingers, but I like to have a nice straight wire to start with, and especially where it comes to the rod I make that couples it or fits it into the body of the wagon. I like to have that nice and straight. So we're going to straighten the wire, and it's done quite simply. I've got myself a hand drill here, but you could do this with an electric drill if you wanted to. I just like the control that I have over the winding with the hand drill. But if you've got a variable speed drill that will give you the same result, well, you use that. Or worst case scenario, just use an electric drill that has no speed control. You'll still get the same effect. And what you do is, just bumping into my clamps here, what you do is once it's secured in the vise and the drill, pull it firmly, pull it tight, I suppose, and then give it a few winds. Just a few winds, and you will see the wire twisting as you do this, and then you release it from the drill. I'll just cut it off there, and then we'll put the drill aside, and then you can release it from the vise as well, just cutting it out there, and we finish up with a perfectly straight piece of wire. Now, it's a good basis to start with. Now, what we use to form the coupling is, I've got this length of aluminium flat bar. This is 10 millimeters across, it's 3 millimeters thick, and you can see there's been some trial and error on here. There's various holes drilled. This is the actual hole I'm using. This is to take a 1.6 millimeter nail or pin, if you like. This has been cut down a little bit, and that will go through this particular hole here into that one. Now, when we put it in and turn it over, you can see that the flat bar has been shaped here. I've got sort of a V shape filed on the top here. That was to get that sort of nice curved shape to the top of the coupling, but also in here I've cut a groove that will receive the wire. So when the coupling is being made, the wire is put into this groove first, and then it's wound around this pin at the bottom. The distance between the top of the groove and the center of the hole is about 4 millimeters. So it's quite small actually, and so that should leave enough room inside the coupling for the magnets to rotate. So this flat bar is about 150 mil long, so I can mount the end near my hand into the vise to hold it stable while I get some pliers to wrap the wire around this. So yeah, so that's what's used to form the shape of the coupling, and it's quite easy, and you get consistent results. So we'll show you how that's done. So the first thing to do obviously is to mount the jig into the vise so that it's nice and secure. I've cut a length of copper wire about 50 millimeters long, and I'm holding that at each end with a pair of pointy nose pliers. And what I do then is bring the wire down into the groove. I'm holding these pliers quite firmly, and then I pull the wire down behind the pin, pull it down quite tightly, and then bring it up and around and about horizontal with the bar there, and then release it. I then come back with one of the pairs of pliers and just give it a squeeze, top and bottom, so that it's nice and tight against the bar, and then we remove the pin and release the coupling. I've got a little pair of snips now, and what I will do is come back to the coupling and snip off the excess copper wire on each side, and that is the coupling formed like that. It fits over the wire, over the bar like that. I think this may demonstrate its very small size as we just sort of move around with it on the rule there. It doesn't take up much room at all. To form the connecting rod which connects the coupling to the wagon, I'm going to use these pliers that they tend to use for jewellery making, for bending wire, and you'll notice on the point it comes down to quite a small diameter and then increases as you move back further into the plier itself. So it's just a simple matter of getting some of the copper wire and holding it at the very end in this case, and we've got the very end of the wire just sticking out a little bit from the pliers there, and we give it a turn right round, not all the way but a good way round, so that we form this hook. I suppose I've gone too far there. I'm going to have to open that out a bit, but that's the sort of shape we're tending towards. I need to open that out just a little bit so that I can slide the coupling in there. So I might as well do it while I'm here. I'll just give it a bit of a twist, and we've finished up with, that's how it's supposed to be. So that leaves enough room to slide the coupling in there, but we're not ready for that yet. So I'll just snip that off at about, I don't know, about 25 mils there, so we can just put that part aside along with the little coupling we made. The next stage is to make the axle for the magnets, and again, this is another piece of copper wire that's about 20 millimeters long. That's more than we need, much more than we need. And to form this, I've got a pair of pointy nose pliers here that I've used over the years and modified over the years, as you can see. So we're not worried at all about these modifications, but what we're more concerned about is that the inside faces of these pliers, they're old and they're worn, but they're nice and flat. So I'm going to use the inside face, or both faces actually, squeezed against the wire to create a flat section in the middle to mount the magnets onto. And in this case, with these pliers that I've been mucking around with over the years, just about there is about the right spot to give me approximately a 4 millimeter flat spot on the wire. Now I can't really do this by hand. I can't squeeze this tight enough to create the flat spot by hand. So what I do is I take the pliers over to the vise to do the job for me. I put the jaws of the pliers in the jaws of the vise and then squeeze them together. So we'll have a look at that. Right, well, whilst we're holding the wire in place within the pliers, just put them part of the way into the vise and then give it a good squeeze, like so, and then release it, and you'll see that the wire is a bit bent, but we've got our flat spot there. So this is what we've created by squeezing the wire in the pliers in the vise. This nice flat area for the magnet to sit on. It's very difficult to get these magnets opposite each other on a round piece of wire. It just won't happen. So you need this flat spot created there to allow them to sit flat opposite each other. So now we've got our 3 copper parts formed up and ready to go. Now the next stage is to add the magnets to the axle there, and then the axle will be trimmed at each end, because obviously you can see it's quite long compared to the coupling at the moment. So there is another jig to trim that, but we'll add the magnets to this bar first and then move on from there. Now to put the magnets onto the little bar here, I'm going to use this jig that I've had for quite a few years now. It's a piece of Perspex, I think, and I've got a neodymium magnet set in it, and you can access the magnet from either side. And so I'll put this in the vise, and then I'll sit a magnet on there, and then I can put some adhesive on the magnet and start fitting the axle, and then another magnet, etc. And all that is done with ultraviolet glue. I have these ultraviolet glue pens, which you can get on eBay, and they're terrific. Basically put the glue on and then you use the light to make it go off. So we'll get set up in the vise, and It's going in the vise simply so that it can hold this in a good position for me to work on. Okay, so we're set up in the vise, and the first thing we'll do is bring over one 3mm neodymium magnet and sit that on there. I'll just get another one separated from its neighbours just to put it beside me here so that it's ready to go. Right, so the next stage is that we now take the glue pen and we'll add some ultraviolet glue to the magnet, and I cover the whole magnet. So that's the beauty of this stuff, that it won't go off on you until it's been hit with ultraviolet light. Now the axle's been prepared and it's brought over, so we just press it into the glue on the magnet, and we can just leave it sit there for a second. You've got to try and position it right in the middle. I'll bring some more glue over just to put on top of that. It might even swim around a little bit. We'll have to adjust it probably. Anyway, there's plenty of glue on there now. I'll just do a final adjustment. That's pretty good. Now we'll bring over the other magnet and try and get it to sit dead flat straight away, and it won't. Of course, they never do. So we have to just fiddle about now, just gently, to get the magnet to sit properly, which it is now, which is good. So now I'll take the jig out of the vise, simply so that I can hold it at a good angle so that I can get the ultraviolet light to shine in on the sides here and hit the glue. So we'll get it set up for that. So now I'm holding the magnet in my hand, and I bring the ultraviolet light over, and it will highlight. You can sort of see the green where the glue is, and when that's highlighted it'll start setting. So this takes about 30 seconds per side, so I'll do that off camera and I'll come back to you. Okay, so it's been treated with the ultraviolet light, so we can just remove it from the jig, and there we have it. I'll do a close-up of this for you so you can see it better. So what we have is this slight gap here in between the magnets created by the flat spot, and the ultraviolet glue has been pressed into there, and then it's been set off with the ultraviolet light, because the light can actually see it in there to make it go off. So on my other bench over here, I've got a little vise, a little table vise, set up with a piece of aluminium angle. There's a hole drilled through here, obviously big enough to take the copper wire. This is about 1.5mm thick, so I just push the copper wire through until it meets the magnet, and then bring the little snips over, hold them flush against the aluminium, and then just snip off the end, and then we finish up with this little bit left out on the end of the magnet there. Turn it over and do the same on the other side. So you always get the same result. Yeah, so that's that. Now we're at the stage here of assembling the coupling, and what I do is I've taken the coupling and I've put it right up to the end of the wire bending pliers, and I'll give it a bit of a squeeze to spread it. So that takes it out to about, I think, 6mm or something like that. So then I bring it back to the end of the pliers, and I'm just holding it with the very end, as you can see there. I hope you can see that. Then I bring the magnets over. Now the magnet will be attracted to the end of the pliers here. So the pliers are holding that for me. So now I can fiddle around and push the magnet into one side of the coupling, and then I'll have to get it into the other side as well. It's difficult to see what I'm doing here with the camera in the way, but now once I've got it in position there, which I have at the moment, I'll just give it a bit of a squeeze with my fingers, and let's see if we can show you. It's actually in the coupling now. Now I've fitted the magnet onto the little jig I had, and what I'm going to do is I'm going to put this jig standing vertically into the vise so that I can fit the connecting rod on as well. So I'll get the vise set up and we'll sort that out. So once I've got the coupling on the jig and set up in the vise, I'll bring the coupling hook connecting rod over, and we'll just slide that on like so. Now I'll just have to bring some pliers in and just give that a gentle squeeze, because I just want to make sure it's not going to come off. So the jig is handy here to hold it in place. If you try and do this with your fingers, it's quite awkward. So that's got it now. It's squeezed up enough, so that's done. Now to check that the coupling is performing properly, I bring that jig back in with the magnet in it, and because I can switch polarity with this, I can just pull that away so that side works. We just turn it around, and there she goes with that side. So we'll try it again. It's rotated obviously to do that, and it's done it again on that side. Now if there's any issue here, the only problem would be that maybe the coupling is squeezing too tight on the magnets and there's not enough sideways movement, but this is okay, so that's quite good. Now where we go from here is setting the wagon up to receive the coupling. I've got a Dremel here in a drill press, which will drill the right size hole to fit this coupling in. This is assuming that you might have had a hook here on the model that's been removed. Whatever's necessary to give you a clear run at the buffer beam there. So we'll do the hole for the new coupling. That should do the trick. Now in some instances here you might run into the weight for the wagon that's in directly behind this. On this wagon it hasn't happened, but I've had it happen on other wagons where the wagon weight is actually in the way, so you need to probably take the wagon apart. And I've dealt with this in a couple of ways. You can actually bend the copper wire behind the buffer beam to avoid the wagon weight, and you can glue it into place, or you can take the wagon weight out and cut a slot into it to accept the copper wire that's coming through. Yeah, unless you discard the wagon weight and use some other way of adding weight to the wagon. But this one, you know, this one's playing along nicely, so we're just using this simple method to do it here. So here we have the coupling fitted to the wagon. The some super glue was run along the shaft that is fitted into the wagon, and then the shaft was pushed into the wagon. This is very hard to film because it all has to be done quickly, so you'll just have to imagine how I've done it, and you know, it's quite a simple method really. Just glue it in place. Now we'll just check how the coupling works with a couple of other wagons. So this is a brake van here. It's working quite well there. I'll turn the brake van around, try the other end. Yep. And we'll bring in another wagon. or a van I should say. So there we go. Too easy. Right, we're ready for the next stage now. Okay, I've mounted the wagon vertically at a nice gentle little vise here with rubber jaws on it. It's just holding it very gently. And what I'm going to do is cut the wire that goes between the buffers, and I'm going to bring that over and fit it onto the buffers. So the first thing I'll do is measure the buffers, which should be around about 23 millimeters from buffer to buffer on the center of the buffer. But I'll just confirm that, and then I'll come back with the wire to do the job, and ultraviolet glue as well. So we've got some digital calipers here to get the correct measurement, and center to center is saying 23.29. So we'll just lock that off at that position, and then I'll go and trim the wire to suit. So I'll use the jaws of the calipers to sort of measure the wire and then trim it off. Okay, we'll just do the buffers now with the ultraviolet glue, and you might think this is ruining the buffers, but it just puts a bit of a dome on them, and once it's painted it looks fine. Now I'm coming in from the top end of the wagon with these special crossover pliers that actually hold items for you until you squeeze the tweezers to release. We've got it there now. I'll line that up with a toothpick just to make sure that it's level, pretty much in the center of the buffer there. It just needs a slight move, and we'll give it a bit of a tap downwards to make sure it's sitting right into the glue. And now I'll come back with the ultraviolet light, and again I do this for about 30 seconds on each buffer, so you don't need to see all that, so we'll just turn off the recording here and I'll get these buffers done. Right, we're nearly finished here, just another couple of seconds and this other one will be done. So that's it. Now we'll just check it on the railway with a couple of wagons. That's fine with that one. We'll just take that one out of the equation, bring in a brake van. Yeah, that's working fine with that, no problem at all. We'll just check the other end as well, because the other end's been done. Yep, no problem. So you can see when they're connected, and if you're pushing the train, they come together. That's why we need the wire across the buffers if you're going through tight radius points especially. So when the buffers slide past each other, they then slide onto the wire and they won't interlock. So all I need to do now, folks, is give this little wagon a coat of flat black paint over these new couplings and the wire and the buffers on both ends, and that takes just a couple of minutes. I won't bore you with that, but what I'll do is I'll put up a picture of it painted up when it's finished. It's an acrylic flat black. It's Tamiya, I think. Yes, Tamiya, and it's a flat black, and it dries fairly quickly. So I do it with a brush. There's no special effort required, and I usually hold the coupling magnet with the little jig again, just to keep it still while I'm painting. So it's, you know, I've got it all down pat. I've got all the methods worked out. So there you go. Okay, so I'll get onto that, and when I've finished, I'll put a picture up after this. So that's all I've got for you with this method, and it seems to be working rather well for me. And of course, I've got a big shunters pole that you probably would have seen in a previous video that uncouples these, but that's another story. But this is really the nitty-gritty. This is what makes it all work. Okay, I'll leave it with you, and enjoy the picture. Cheers, Gorman.